Welcome to My Dreams Academy.
Good day, friends. Welcome to another episode of My Dreams Academy online tutorial. I'm your tutor, Emmanuel Prime, and today I'm going to be teaching you about transformers. Okay, now what are transformers? Transformers are electrical devices that are normally used to control alternating voltages in a circuit. Okay, now what does that mean? If you look at transformers, we said that it is used to control alternating voltages in a circuit. Okay, now transformers make use of what? Alternating signals. Okay, they don't make use of direct signals. Okay, good. So that means that if I pass a direct signal into a transformer, I won't obtain a reasonable result. Okay, that is one of the advantages that alternating signals have over what? DC signals. You can easily step down or step up an AC signal, but you can't easily step up or step down a what? A DC signal. Okay, so under the transformers, I'm going to be teaching you about the structure of a what? Of a transformer. Okay, the structure of a transformer. Now, but before that, we have different types of transformers. Okay, we have power transformers, we have auto transformers, we have different kinds of transformers. Okay, that you can't even list all of them. Now, but basically, we're going to be talking about the two types of transformer, which is the step-up transformer, and then we're going to talk about the step-down transformer. Okay, so these are the two types of transformer we are going to be talking about today. Other types are also there. Now, no matter the type of transformer we have, we always have two important coils, okay? Two important coils. What are those two important coils? We have the primary and the secondary coil, okay? So I'm going to represent them basically this way, okay? So if I have this as my transformer core, I have on this side, I have coils of wire on this side, and I also have a coils of wire around this side. Okay, so these are coils of wire on this side and this side. Okay, now the one on the left hand side here, through which I can put in my voltage, this is my inputs. This is my input side. Then I can also obtain my voltage here. Okay, so this is what? This is our output. Okay, now the input of any transformer is always known as the primary of the transformer. Okay, and then the output of the transformer is known as the secondary of the transformer. Okay, so that is the basic structure of a what? Of a transformer. So here I'm going to call here my primary coil, and then we have our secondary coil. Okay, so these are the two coils of a transformer, the primary coil and the secondary coil. Now these two coils are wound on a what? On an iron core. This is an iron core. This is an iron core. Okay, so that is the basic structure of a transformer. Okay, so now we are going to talk about those two types of transformer I told you earlier, the step up and the step down, and know what actually makes them different. Now, for a step up transformer, let's talk about the step up. For the step up transformer, look at the structure of that transformer. Okay, so they follow the same thing. Okay, so we have our primary here. This is our primary and this is our secondary coil for a step-up transformer. Now, just like the name implies, a step-up transformer is used to what? To increase the magnitude of a voltage. Okay, so if I want to increase the magnitude of a voltage, what do I use? I use the step-up transformer. Okay, so if I put in a low voltage, if I put in a low voltage on this side, I will get a high voltage. I'll get a high voltage on this side. Okay, that is what a step-up transformer does. So low voltage inputs, I will get a high voltage output. Now the reason why that happens is because if you compare the number of turns, okay, in the secondary you have more coils of wire than the primary. Okay, so because of this number of turns in the secondary, that is why you have a high voltage at the what? At the secondary side. Is that okay now? Now, another thing you need to know about the step-up transformer, now it steps up voltage. Now, but it does the opposite to the what? To current. Now, so if I have a step-up transformer, it does not step up the current, it steps down the current. So that means that in my primary, if I have a high current, if I have a high current in the primary, I will get a low current in the secondary. That is what a step-up transformer does. Okay, and then we can apply the step-up transformer in what? In power transmission. Okay, if you understand how power is being transmitted from the generating station, it is being what? Imputed or passed into a step-up transformer. Now, this step-up transformer can actually increase the magnitude of the voltage so that it can be transferred over a long distance. That is what a step-up transformer is. Okay, so for a step-up transformer, if we use NP to represent the number of turns in the primary, and we use NS to represent the number of turns in the secondary, then for a step-up transformer, we can say that NP is less than NS, meaning that the number of turns in the primary is less than the number of turns in the what? Secondary. Good. Okay, so we're going to talk about the next type of transformer, which is the what? The step down. The step-down transformer, or the step-down transformer. Okay, they have the same structure. They have the same structure this way. Now, but when you come to the primary turn for the step-down, it has more turns like this. Okay, now, but here has only few turns of wire on this side. So this is still my inputs. That is my primary, and this is my secondary. Okay, now if you look at the step-down transformer, just like the name implies, it steps down the voltage, it steps it down. So that means that if the voltage is too high and you want it to become low, you use a step-down transformer. That is what it does. Okay, so that means if I have a high voltage on this side, high voltage, then on the secondary I will get a low voltage. Okay, now just like I told you that in the step-up transformer, that a step-up transformer increases the magnitude of the voltage, meaning at the primary we have a low voltage, at the secondary we have a high voltage. Now the opposite will happen for the current. Now the same thing happens here. Okay, now for the step-down transformer, a high voltage at the primary leads to a low voltage at the secondary. Okay, now but in current it is the opposite. So what happens? If I have a low current, in the primary, then I will have a high current at the secondary. Okay, so that means that the step-down transformer, what does it do? It increases the magnitude of the current. Okay, but a step-down decreases the magnitude of the current. Now, here the same thing, if we use NP to represent the number of turns in the primary, and we use NS to represent the number of turns in the secondary, then we can write that NP is greater than NS. Okay, so that means that the number of turns in the primary is greater than the number of turns in the what? Secondary. Okay, so now we're going to talk about the principle of operation of transformers. Let's see how exactly they work. Okay, so for us to be able to understand how transformers work, I'm going to use a step-up transformer to illustrate that. Now remember that a step-up transformer is a kind of transformer that has more secondary turns than the primary turns. Okay, so we have this, but the secondary has more coils of wire, more turns of wire than the primary. Okay, so this is my inputs and this is my outputs. Okay, so how does this work? Now, whenever I input a voltage, now remember that the voltage we normally use is what? An alternating voltage. So whenever I input an alternating voltage, what happens? Now, this alternating voltage creates an alternating magnetic flux in the primary coil. Now, this alternating magnetic flux is then transferred to the secondary coil. Okay, now because this magnetic flux is transferred to the secondary coil and the secondary coil has more turns, so you see that a larger EMF will be induced in the what? In the secondary coil. Now this process is what we call mutual induction. Okay, so mutual induction simply means the what? The induction or production of current or voltage in a coil because of the vibration of what? A neighboring coil. Okay, so if you look at this secondary coil and the primary coil, they are together. Okay, now but what happens? It is through the input of this primary that I put in a voltage. Now, but this voltage was transferred into the what? Into the secondary coil. There is actually no contact. Okay, now mind you that these wires we have here are what? Are insulated. So there is no way that current will move from the primary coil to the what? To the secondary coil. Okay, it is only due to what now? Change in magnetic flux. And if you don't understand the concept of magnetic flux, kindly look at my previous video on electromagnetic induction so that you'll be able to get a clearer view. Okay, so like we explained earlier, if I pass in a little voltage through the primary, what happens? It creates a changing magnetic flux. Now that changing magnetic flux is then introduced into the what? Secondary coil through a process we call mutual induction. Now when that magnetic flux is produced in the secondary coil, it converts it to what? To an EMF, a larger EMF. Is that okay now? Good. Now we're going to talk about the transformer equation, okay? Now the transformer equation I'm going to be giving to you is going to be the ideal transformer equation. Now mind you that ideal transformers don't exist, okay? They don't exist. Good. Now, so for an ideal transformer, and mind you, when I say ideal transformer, it means what? A transformer that there is no energy loss, okay? Any transformer that there is no energy loss, we call it what? An ideal transformer. Or in a simpler form, you say that the transformer has an efficiency of what? 100%. Okay? So that is, efficiency is 100%, which is not possible. Okay? So what happens? If we assume that that transformer is an ideal transformer, then we can say this equation that NS over NP is equal to VS over VP is equal to IP over IS. Okay, so what does that mean? NS simply means the number of turns in the what? In the secondary. NP means the number of turns in the primary. VS means the voltage in the secondary, and VP means the voltage in the primary. IP here means the current in the primary, and IS means current in the what? In the secondary. That is the transformer equation. Okay, so now we talk about real transformers, okay? We've talked about ideal transformers. Now, in real life, the kind of transformers we use don't have efficiency of 100%, okay? At least you can get an efficiency of 95% or even 90. If you get 85, it is a very good transformer, okay? Now, the reason why a transformer cannot be 100% efficient is because of different forms of energy losses, okay? We're going to be considering the major forms of energy losses in transformer. Now, the first one is what? Energy loss due to what we call eddy current, okay? Eddy current. Eddy current. Okay, that is the first way that a transformer can lose energy. Now, when we say eddy current, if you observe in that transformer coil, in the design of the transformer coil, now remember I told you that this is the soft iron core. Now, but when you look at it this way, you think it is just a bunch of iron. No, it is not. It is not a bunch of iron. It is actually a what? A slice of metal. You know what I mean by slice? You know there's a difference between sliced bread and the normal bread. A sliced bread means that, of course, you can take it one after the other. But a normal loaf of bread is not sliced, okay? So the iron you are seeing is actually what? Slices of iron that are placed into the transformer, okay? So you can easily remove each slice. Now, the reason why the coil is designed that way is to reduce what we call eddy current. Now, eddy current is normally generated whenever a metal is what? Oscillating in a magnetic field. Okay, so the reason why we have slices or sheets of metal as the iron core is because so that we reduce energy loss by what? Eddy current. Okay, so if you want to reduce eddy current in the transformer, you are going to make use of what? Laminated iron cores. Okay, so that means that this iron core, this slice of metals, you must what? Laminate them so that eddy current is what? Minimized. Now, the next source we can number 2 is what we call the I square R loss. Okay, the I square R loss. Now, this is also called the heat loss. Okay, heat loss. Now, what happens if you look at the coils of a transformer? They are made from wire. These wires did not fall from heaven. Okay, so these wires also have resistance. Is that okay now? So because of their resistance and the amount of current flowing through them, there is always what? Energy losses. Now, for you to minimize this energy loss, all you need to do is what? To use thicker wires, okay? That is wires that have large surface area. Remember that the resistance of a wire is inversely proportional to the what? To the area of the wire. So that means if you need a low resistance, you get a high area. That is wires that are big enough, okay? That is one way of reducing the I square R loss. Okay, so another source of what loss of energy in the transformer is what we call
Just continue.
Is okay, we call it the leakage of magnetic flux. The leakage of magnetic flux, that is the third form of energy loss in the transformer. Now, remember I told you that in the operation of a transformer, that whenever we pass in a voltage through the primary coil, what happens? The voltage we pass will induce a what? A changing magnetic flux in the primary. Now, this changing magnetic flux is transferred to the secondary coils, which will now produce a current. Now, if the flux produced in the primary coil is not totally transferred to the secondary coil, okay, that means that some flux has been lost. Is that okay now? So let's assume that 100 flux were produced in the primary coil and then 80 were transferred. You see that we've lost what? 20. It will lead to what? An energy loss. Okay, so these are the three major sources of what? Energy losses in transformer. Okay, so we're going to solve some questions from our compiled and see how those formulas we said earlier can be applied. Okay, so we're going to take a question from UNN past question. In 2005/2006, number 11, UNN asked the question under the transformers. Okay, they said a transformer has a primary coil with 500 turns. Okay, so that means NP equals 500 turns. Okay, and a secondary coil with 2,500 turns. Okay, so that means NS is 2,500 turns. Okay, then I said when the voltage input to the primary is 120 volts, the output is, okay, so that means they gave us the input voltage through the primary, that is VP is equal to 120, and they're now asking us to find VS. So VS is unknown. Okay, so we use our transformer equation. So remember I told you that for an ideal transformer, that NS over NP must be equal to VS over VP. So we just apply the equation and we get our answers. NS from the question is 2,500 over NP is 500 equals VS is unknown over VP is 120. So we're going to have 0 cancels 0, this cancels this, 5 here is 1, 5 here will give us 5. Okay, so we have 5 over 1 equals VS over 120. So we cross multiply and make VS the subject. So VS becomes 5 times 120 gives us, that is 5 times 120, and VS becomes 5 times 120 gives us 600 volts. Okay, so our secondary voltage is 600 volts. That is option B. Okay, so with that, we've come to the conclusion of this video, and thank you very much for watching the video. Please don't forget to subscribe to our YouTube channel and click the notification icon so that you'll be notified of our subsequent video, and also don't forget to share the video to your friends. Okay, thank you very much. See you next time.
Welcome to My Dreams Academy.